Welcome to the Nutrient Loss Model tutorial series. This is the second video in a series of tutorials created for the Weber State University Nutrient Loss Model team, or NLM team for short. This video covers accessing, downloading, and modifying burn severity maps for use in WebCloud PEP erosion models. First, let's go over some background information. A burn severity map is a raster that describes the burnt conditions of the landscape after a fire. The NLM team currently accesses this kind of fire data from two main sources, the Bear Imagery Support Program and the MTBS database. The acronym BEAR stands for Burned Area Emergency Response. BEAR teams are interagency teams of professionals who assemble to stabilize post-wildfire conditions on federally managed land. Teams may be composed of hydrologists, archaeologists, vegetation specialists, and scientists from other disciplines. Within 7 days of a wildfire, the Bear Imagery Support Program sends satellite imagery and other data to the Bear team, including a classified satellite image describing the burn severity in the landscape. This image, called a bark, shows the changes to vegetation cover by comparing near and mid-infrared reflectance values. Equipped with a bark, the Bear team will take soil samples in the field to verify or make adjustments to the burn severity classification. The final product is a 5-class soil burn severity map. The MTBS program encompasses fires across all of the United States, not just those on federally owned lands. The methods used by the MTBS program to create classified satellite imagery are nearly identical to those used by the Bear Imagery Support Program. Data available for download from the MTBS site includes a 6-class DNBR image. The class breaks for the first 4 classes are identical to those used to create a BARC 4. The 2 additional classes contain data on cloud masking in areas with increased greenness. Now that you know a bit more about burn severity maps, let's go over how to work with them. Step 1. Download a burn severity map. An easy way to find the Bear website is to search for Bear Soil Burn Severity using Google. Click on Data Download to access the database. Bear Soil Burn Severity maps are available for fires that have taken place between the present and the year 2012. Fire records prior to 2012 consist of DNBR and BARC imagery, located in the preliminary data column. WebCloud can use both 4-class and 256-class imagery. DNBR6 imagery from the MTBS database can also be used once it has been reclassified. You can easily access the MTBS site from the Bear Imagery site by clicking on the tab in the upper right-hand corner of the Bear homepage. Currently available datasets span the years 1984 to 2018. If you know the year of the fire you're interested in, the easiest way to locate the imagery is through direct download. Select the year that the fire took place. Select the state. The Coal Hollow Fire of 2018 burned tens of thousands of acres along Utah Highway 6, which you can still see the signs of today. Extract the zipped folder to the Burn Severity Maps folder. I use separate folders to keep track of where the imagery came from. You may find that you need to unzip the folder twice. When you have successfully unzipped the folder, you will see a list of files similar to this one. To work with DNBR6 imagery from the MTBS site, or to modify burn severity, you will need to reclassify the image. Once you have downloaded the fire data, open a blank map in ArcGIS Pro. Add a folder connection to your burn severity maps. Drag and drop the image onto the map frame to open it. This is the DNBR6 image of the Coal Hollow Fire, which I downloaded from the MTBS site earlier in this tutorial. In order to work with this fire in WebCloud, we need to reclassify the image from 6 classes to 4 classes. The 2 extra classes, Increased Greenness and Cloud Mask, will be reclassified as No Burn and No Data, respectively. In the Geoprocessing pane, locate the Reclassify tool from the Spatial Analyst toolbox. Select the DNBR6 image for your input raster. The reclass field defaulted to value, which is what we want. Now we will specify which classes to change and what to change them to. The class value 5 represents increased greenness. We are going to give all of the pixels with the value 5 a new value of 1, which represents unburnt conditions. We will similarly reclassify the cloud mask pixels to have a value of 0, which represents areas with no data. Save the new raster in your maps collection. It helps to use a name that describes what processing steps have been done to it. Click Run. The tool ran successfully, but the classes have been drawn in different colors. In order to make comparisons between rasters easier, you can click on the legend to bring up the symbology window. Right-click on each color box to change it. Now, in addition to modifying DNBR6 imagery, the NLM team also uses reclassification to simulate recovery after a wildfire. To do this, we shift the values of a classified burn map by 1 and 2 increments, which we call Shift 1 and Shift 2. In a Shift 1 file, the areas with low severity burns have been reclassified or shifted to unburnt conditions, while areas with moderate severity burns have shifted to low severity burns, and so on. In a Shift 2 file, the classification value has been moved by 2, changing moderate severity burn areas to unburnt conditions and high severity burn areas to low severity burnt conditions. As you click to toggle through the layers, you can see the progression of burn severity in your classified imagery. Good job! Now that you know how to work with burn severity maps, you're ready to run a web cloud simulation. Find out how in our next tutorial.